All right, number 14 is asking us to match the graph with the equation, and it does say to not use a calculator. So we can do this. On the first one, the minus sign, remember, or the negative sign that's in front, remember that makes it a reflection. So all we have to do is look at our graph. So we see any that open down. That would be this one. So I'm going to say C is going to go with 1. All right, let's look at the next one. We have a number that's greater than 1 in the front, so that is going to be a vertical stretch because it's going to make it skinnier. So it looks like this one, because the vertex has stayed the same, it hasn't moved at all, so it just got skinnier. So that's going to be this one. And then the last one, the minus 3 in the parentheses is going to make it have a horizontal shift. And it will be 3 to the right. So if you look at this one, this is where the parent function starts, and it's gone over 1, 2, and now 3. So, of course, B would be for number 3. Okay, so let's look at number 15. It is saying the cheerleaders at Shadow Creek High School launch t-shirts into the crowd every time the Sharks score a touchdown. The height of the launched t-shirts can be modeled by the function h of x equals negative 16x squared plus 48x plus 6, where x is the time in seconds and h of x is the height in feet. Okay, so if we think about this as a graph, because I'm visual, I kind of need to know this. So x is going to be my time, so I'm going to write my time down here. And then the h of x, which is like my y, that's going to be my height. So I'm going to put height up here. Okay, so it says, at what time does the launched t-shirt hit its maximum height? So we know that if we're launching something, guys, it's going to go up like this and then down like this, right? So we're looking for the maximum height, that'd be this. And it says at what time. So when I find this point, I need to know this value right here, whatever that x value is, right? Okay, so we can go to the calculator to figure that out. So let's head that way. Okay, so we need to do Control Doc to add a page. I want to add a graph. My equation is negative 16x squared plus 48x plus 6. And there's my graph of my equation. Okay, so now you guys, we can't see the top of it, right? We can't see that maximum point. So we can, however, go to Menu, and let's go to number 6, the Analyze Graph. And then we are trying to find the maximum point, correct? So let's go to number 3 where it says maximum. And then there's that dashed line. So I'm going to move this dashed line to where it's going to be to the left of my point. Remember, my point is going to be somewhere up here, right? So I just want to the left of that point, and I'll hit enter. And then I'll move it over here to the right of that point, and I'll hit enter. And then, oh, did it not hit enter for me? Let's try it again. Okay, there we go. All right, so we have this point right here, right? 1.5. I'm going to write it right here, 1.5, and then 42. Now remember, we needed the x value because it was asking for the amount of time, I believe, right? So let's go back. Here's the paper. All right, so it just says, at what time does the launch t-shirt hit its maximum height? So yes, so the time is going to be 1.5 seconds. And then the second part says, what is the maximum height of the launch t-shirt? Okay, well, so we can use the same point. 42 feet would be my maximum height, okay? All right, number 16, kind of doing the same thing here. It says Emilio is competing in the javelin throw. The height of the javelin can be modeled by the equation y equals negative 16x squared plus 64x plus 4, where x is the time in seconds and y is the height in feet. So again, if we look at it on a graph, the x is the time, so my time is down here, and then the height would be my y value, okay? So it says, what is the height of the javelin after 2 seconds? So again, remember, it's going to go up and then it's going to come down, right? And we want to know what the height is going to be at 2 seconds. Might not be the maximum, so let's go see what we can do if we put this into a calculator. All right, so here we're back at the calculator. Hit Control-Dock to add a page, do a graph again. The equation is negative 16x squared plus 64x plus 4. Negative 16x squared plus 64x plus 4. There we go. And again, see, we can't see the height, but that's okay. Remember, we were just trying to figure out what it is for 2 seconds, like right here, right? So all we need to do is go to Control-T to get to the table. And then we're looking for the 2. Right here is the 2 for the x, so that means this must be what the height is. And so that's going to be at 68. So if we go back to our paper, and let me move this back over. Okay, so for the height, what is the height of the javelin after 2 seconds? Remember, what was it? 68 feet, right? Okay, there we go. Okay, number 17 says a summer program for children includes daycare that costs $500 per month. This also includes 5 field trips of your choice per month. If you would like to purchase extra field trips beyond the 5 that are included, they are $20 per trip. Which equation represents the cost per month of daycare if x represents the number of field trips where x has to be greater than 5? Because remember, the first 5 are included, so we're looking for the number greater than 5. So let's think about this. So we know it's going to cost us $500. And then if we want to pay for extra, it's going to be $20 per trip, right? So you would kind of think it would be 20x. But remember, my x has to be greater than 5. So to show that, we can do this. So as long as that x is greater than 5, then we should be able to figure out how much it's going to cost, okay? So it looks like B is going to be our correct answer there, okay? Okay, let's look at number 18. It says find the domain and the range of the relation. Remember, the domain would be the x values, and the range would be the y values. So let's look at the domain first. Notice that I have individual points on here. So when I'm looking for the domain, I'm going to go to I'll have individual numbers is what I'm trying to say. Okay, so I've got 2 points right here. They both are would be at 0. This one would be at 1. This one would be at 2. And this one would be at 3. So my domain, we can write it over here, would be 0, 1, 2, and 3. Okay? If I look for my range values, remember those are the y values. So I've got a point here, I have 2 points here, I have 1 point here, and I have 1 point here. So let's see what those numbers would be. So my lowest value is -1, -2. And then I go up to 1. This one is at 2. And this one would be at 4. So there would be my range values. Number 19 is asking me to find the area of a rectangle with length 2x plus 3 and width x minus 1. Remember, the area of a rectangle, the formula is just length times width, right? So I'm just multiplying. So here's my length is 2x plus 3. My width is going to be x minus 1. So I can multiply this by either doing FOIL or the box. So your choice. I think I'm just going to go ahead and try to do the box for us. So here's my box. I'm going to take one of these, we'll say 2x, and then plus 3. We'll put that on the top. The x minus 1, I'll put over here on the side. And then I just have to multiply. So x times 2x, right here, I'm going to get 2x squared. X times 3, I will have 3x. -1 times 2x I'll have negative 2x. Negative 1 times 3, I will have negative 3. And then remember, these would probably be like terms, so my answer will be 2x squared. And then I'm going to add these together, so I have 3x plus a negative 2x, which will end up just giving me 1x, and then I have a minus 3. So there would be my area for that rectangle. Okay, number 20 says to graph the linear inequality. Because it's in slope-intercept form, we can do this pretty quickly by hand. My slope is negative 1/2. My y-intercept is 3, so I go up to the 3, and then I'm going to go down 1 and over 2, down 1 and over 2, or up 1 and over the other direction by 2. And because it is greater than but not equal to, this is going to be a dashed line. And then because it's greater than, we are going to shade above. So all of this area right here is going to be shaded. Okay? All right, let's look at number 21. It says graph the system of equations. Okay, they're not in slope-intercept form, so not as easy, so I think I'm just going to go straight to the calculator, and let's see what we can do. All right, let me move this over. So we're at the calculator. Again, I'm going to go to another page, so Control Doc. Again, I want to do graph. And because they're not in slope-intercept form, remember I'm going to hit delete over here. And I want to go to number 6, the relation. And then I can type in my equation. So it is 2x plus 5y equals 11. So there's my first one. To get a second spot or a second line so I can graph another equation, I go to tab. Let's type the next one in. 4x plus 3y equals 1. And hit enter, and there would be my other one. Okay, my last question is asking me to find the x and the y-intercept. So remember, if I want the x-intercept, that means my y value is going to be 0. So really this is gone, and it just leaves my 2x equals 8, and then divide by 2 on both sides. And then that's going to leave my x would be equal to 4. So if I wanted to write it as a coordinate, it would be 4, 0. And then if I did my y, my x value is going to be 0. So that really means this is gone, and it just leaves negative 4y equals 8. So to solve for negative 4y equals 8, I am going to divide by negative 4 on both sides. So that will leave me y equals 8 divided by negative 4 is a negative 2. So my coordinate for that point would be 0, negative 2. So this would be my y, and this one would be my x. All right, good luck on the test, you guys.